Hello, everyone, and welcome back. Today, I'm going to be talking about graphing linear equations. So, here it says only 2 points are needed to graph a linear equation. And that's true, right? Because if we have any 2 points, we can just connect them and then we have our line, right? So if we have any 2 points and we know those are 2 points of a linear equation, we can just connect them and we're good. Now, when we have an equation, that's also enough because it means we do have 2 points, right? The slope and the y-intercept are used together to graph linear equations using the following steps. So step one, graph the y-intercept, and this allows us to plot the first point. And then from the y-intercept, use the slope to plot the second point. Okay, so let's do that. Let's do that. And I'll talk about step by step how we would do that. So first things first, we need to graph the y-intercept. So how do we do that? Well, I can see the y-intercept is 2, right? And that goes for any equation, whatever our b value is, right? Because this is the same as y equals mx plus b. Whatever that plus whatever is, that's going to be the y-intercept, okay? So that value is going to go here, 1, 2, right? Or in other words, when x is 0, y would be 2. So we're going to plot 0, 2, which is right there. Then we have the slope is 2/3. And remember, a slope is the change in y over change in x, or it's rise over run is another way to think about the slope. So in this case, the rise would be 2, so we're going to go up 2 again. And then we're going to go across 3. The run is 3, 1, 2, 3, like that to plot the next point. So now I'm going to get rid of this one. This was just a placeholder for me. And then I'm going to draw this line through. And there we go. Okay, I'll do this a few more times as well throughout. There's 6 of these looks like, so I will do this another 5 times to show some different examples where maybe we have a negative b, or what do we do if we have a negative slope or things like that. So not to worry, we will get into other examples as well. So let's try for b. For b, it says negative 4 over 3x plus 5. So what's our b value? It's that last part of the equation. It's that plus 5. So I'm going to find 5 in here. There we go. There's 5. And then I need to find the next point using the slope. So again, the slope is rise over run, which is negative 4 over 3. So what's our rise? Our rise is negative 4. So that means we're going to go down by 4. So down 1, 2, 3, 4, down to here, right? Oh, this is just, I'll put this actually in as a green dot because this is just our placeholder. This is not actually a point. And then we're going to go 3 to the right. 1, 2, 3, and there we go. Now let's get rid of our extra green dot, and I'm going to draw my line. That. Actually, you know what? There's a tool on this thing to draw a nice straight line, and I think that's really what I should be doing. I should be drawing a nice straight line, not a curved one. Oh, no, but the line needs to go through both points. That is very important. Let's try again. Oh. All right, there we go. You know what? That is good enough. Perfect. Very good. Now, the other thing with a negative slope is that the slope goes downwards, right? It's a slope that goes down as to a slope that goes up whenever it's negative. So if you plotted it incorrectly, then it might look like it's going upwards. But a negative slope always means we're going downwards. The fact that this goes to show us that we're doing it correctly. Okay, so that's important. Okay, let's move on to C. Y equals 4x minus 3. So in this case, our b value is what? It's this last part here again. It's negative 3. So negative 1, negative 2, negative 3 is right down here. And then our slope is 4, right? So remember that slope is rise over run, and that 4 is the same as 4 over 1, right? 4 over 1 is the same as 4. So therefore our rise would be 4. So we're going to go up 4 up to here. And then our run is 1. We're going to go 1 beside right there like that. And then we're good. Okay. And then let's draw that line. Oh, let's make sure we get both points on that line. Yep, there we go. That's good. Awesome. Okay, let's do D next. Okay, so D is negative 5x plus 3. So what's our B value? It would be 3. So we'll start up here for 3. And then we have negative 5 as our slope, right? So negative 5, that's the same as negative 5 over 1, right? So our rise is negative 5 and our run is 1. So since our rise is negative 5, we're going to go down 5 down to here, and then we're going to go over 1 like this. And again, when we connect these two lines, it's going to slope downwards. It's going to be getting smaller, smaller, smaller. And that's exactly what we want because we do have a negative slope. Oh, that's not quite right. Oh. I'm going to try to draw it accurately, yeah. Normally the way you draw it accurately is with a ruler, but on here, I don't know how well a ruler would work, although perhaps that's an option I should consider, is just getting a ruler. Okay, but there we go. That's not too bad. That's good enough. Good enough. All right, let's do E. This one is negative 5 over 2x plus 4. Okay, so where's our y-intercept? It's at 4, so 1, 2, 3, 4. It's going to be there. And then our slope is negative 5 over 2, so negative 5 over 2. And when we have a negative just kind of in general, we could put it at rise or run, doesn't matter. I tend to just put it on the rise. But either way, we'll get the same thing because if I do negative 5 over 2, I'll be going down by 5, so I'll get down to here, and then I'll be going over 2, and we'll get to here, right? Now, let's say I do, the rise is plus 5, right? I would get up to here, 1, 2, 3, 4, 5, so I go off the grid actually, and then negative 2 for run, I would get here, so I'd go 1, 2 to the left. So either way, it's not going to get us the same dot, whether we put it on the top or the bottom, but it is all part of the same it is all part of the same line. Just this one kind of goes off the grid a bit, but it is still going to get you a correct second point. Because reality is, there's infinitely many correct second points. However, we're just choosing, the simplest one, which is the one next next in line, so to speak, to that first point we plotted. But there's no actual wrong answer. I could give, if you were given 2 points that have nothing to do with the y-intercept or anything like that, and you connected them, you would still be correct. And so that's something I want to make clear as well, is that regardless, you're still going to get what you need to get, right? There's not just one, there's a lot more than one correct, next step to go and do. This is just the simplest one, and so this is the way we're doing it here, for just simplicity's sake of, let's just plot the next most obvious one kind of thing. Good. Okay, and then here we have y equals 7 over 3x plus 4, or minus 4. So of course our y-intercept is minus 4, so there's our first point. And then what about our m value? That is going to be 7 over 3, so that's rise over run. So that means we're going to go up 7, so we're going to go up 1, 2, 3, 4, 5, 6, 7 right there, beautiful. And then we're going to go over by 3, so 1, 2, 3, it's excellent. Very good. And then, there we go. We did it. It is excellent. So there we go. There we have it. So yeah, so that is how we can graph linear equations. I hope you learned a lot from this session, and I will see you guys again next day. Bye, everyone.